Okay, so welcome to the first ever Fluid Intelligence Industry Snapshot session. We will be launching a series of this kind of a short 30 minutes sessions during the coming months, covering different parts of industries and mainly regarding the online oil performance monitoring. And today, our first session covers gas engines with our real life customer case from a Nordic energy utility called Vatanjokosken Energy. And we have got quite an enormous amount of preliminary questions, so we aim to address those questions in the end of the session. And now, while people are presenting, I hope you can type your questions on a communication box, and if we have still some more time, then we can open the microphones and have live questions. Now, my name is Mika Perttula. I'm the CEO of Fluid Intelligence and your moderator today. Our key speakers are today my colleague, the founder of the company, Mikko Oksanen, and our great partner and distributor from the Middle East, Mr. Muhammad Nasser Uddin from Asset Reliably. But first, a quick introduction to Fluid Intelligence. The company was founded early 2016 to serve heavy industry and logistics sectors, mainly in the areas of oil performance monitoring and professional services. Today, we serve almost 100 customers already on different regions, and our partner network covers many parts of the world so far. But quickly, before going to our real-life customer case, let's start our today's session with an update regarding the current crisis. I hope that all of you are well and safe, as this has been quite a shock on a personal level for many people, but also on the professional side, as we are seeing many times that many factory areas are closed and employees may not be able to attend the working places, but also we are seeing that different experts and contractors might have restrictions in access. Of course, we are also seeing many different routines interrupted, like if you are doing an annual or quarterly oil analysis, for example, taking an oil analysis and taking it to the lab might be interrupted. Also, when you have like regular maintenance break, there has been challenges, and like we have seen in Scandinavia, that few professional services projects and monitoring delivery events, those have been postponed until end of May. So many challenges, but also on a logistic change. So even when you are having a maintenance break, it might be that it impacts the logistic of spare parts or even oil that you are expecting to your site. So we are facing something really new and big, and it makes us to think that how can we perform our work as we've used to done, and how we can really make those critical assets run as reliably as possible. So, well, I think it's time to start thinking proactively, and hopefully today's session give you some answers and potentially some fresh ideas how we could tackle this challenge and mitigate these challenges even a bit in this situation. But now, without further ado, I want to give a stage to my colleague Mikko Oksanen, who will run through the case gas engines. So please, Mikko.
Yes, very good.
Great.
Very good.
Please, go ahead.
So my name is Mikko Oksanen. I'm the founder of the Fluid Intelligence, and I'm happy to present you a case from our customer with gas engine. As you can imagine from the color of here, this is case of GE Genbacher, and exactly the GenPaher is very, very fruitful for us. Since this case, GenPaher has actually defined that there is no defined oil change interval, but there is a oil analysis interval which should be followed, and a very exact thresholds which should be followed, and those if those thresholds are met, then the oil should be changed. The oil brand actually doesn't affect this at all, but they also, of course, in other cases, they might also affect. This GenPaher manual oil condition requirements includes various parameters: oil performance, viscosity, impurities, additives, and of course wear metal, and so on. And this case, customer was following at least this. Before. These were done. Okay, we can go forward. Please, next. This was done every second week, since they were using landfill gas, which is requiring from the gas engine. Oil change interval was monthly or bi-monthly, and still there is a picture of soot coming out to the new oil, which is just changed. Remote location also generated extra cost for customers, so the oil handling for customer was quite expensive. Every second month oil change, every second week oil sample. An oil sample must be sent to the Holland for the analysis. Well, please, next slide. We installed Fluid Eye Trend to see whether we can improve the customer situation. Very well. In the testing period, we decided already that, okay, we will make this a case where this is recorded that, okay, oil monitoring works as it is designed. So we followed all of those values GenPaher, so OEM required, and made it clear that they all correlated with our online monitoring trend. There is presented viscosity, there is total acid number, total base number, oxidation, nitration presented in this picture, but of course all other were also followed. In the end, you can see that, okay, the values are from new oil. Okay, with this data, we could see that the oil monitoring trend was correlated perfectly with oil condition, and with this information, customer was only required to do only few of the oil samples anymore. Actually, customer had not done any oil samples this year, since they don't care, since they can use only the online monitoring. Please, next slide. So, Fluid Eye Trend, we could have a clear picture of the development of the oil condition. Also, when a customer had oil cooler oil water leak, we could see the spike at customer's engine and tell the customer that, okay, maybe this issue must be addressed. And this could be done about half an hour it has occurred at customer. Customer was able to prevent major failure escalation. Alongside, they were able to extend the oil sampling. And please, next slide. Very well. End result. Oil sampling costs were down quite a lot. Customers don't have to plan logistics, taking samples and sending them to laboratory. Customers have possibility to take them, but they actually don't do them, and they randomly select a time that, okay, everything is fine, but it's not required. Customer oil change interval at the moment is based the information that is provided by fluid oil trend. So that means that, okay, before they change 6 to 8 times a year the oils, at the moment they have changed 3 times a year, 4 times if you calculate the failure you saw from the oil cooler water leak. They can see if there's production losses and reduced waste oil streams. I suppose my time is up already, but I hope you got the picture how and what we did. Thank you. Mika. Or Mohammed, it's your turn now, so please, Mohammed, continue.
Hello, everyone. Can you hear me?
I can hear you, Mohammed.
Okay, excellent. I am Mohammed Nasiruddin. Maybe some of you might already know me from my LinkedIn activities, mostly on machinery lubrication. My background is, maintenance and reliability in for the last 20 plus years. And I would like to add up some points related to the current situation and the need for online oil monitoring, because in my perspective, basically the purpose of condition monitoring is to detect the problems as early as possible. But unfortunately, the conventional oil sampling and analysis, lab analysis, is having a lot of drawbacks because of so many factors, from sampling till the lab analysis, the delays associated with oil analysis. And in current situation, a lot of labs are still not receiving the samples which they were receiving in past because of this pandemic. And the manpower on the plants have been reduced, which is causing a lot of problem in getting the oil samples taken at the routine. So all these affecting the current, a lot of machines are undetected for their current health of oil in present scenario, and which is a very risky situation, because it can lead to sudden failures. And that's why the whole purpose of condition monitoring will not fulfill. So the purpose of condition monitoring is to be proactive in avoiding failures, and instead of being reactive. So for the past, in historically, there were limitations with we used to see a lot of online monitoring systems, including vibration, performance, and process parameters monitoring. But historically, we haven't seen much work in the industrial oil analysis with the online option. So there were limitations related to the accuracy of the sensors and sensitivity, and also the cost associated. But with the past decade, a lot of research and development has been done, and the sensors are now much more accurate and sensitive to detect the early warning signs of oil condition. And also they have been quite cost effective. And the need for the oil, and it is the time now to move ahead for the application of industrial Internet of Things into online oil monitoring. And while selecting any sort of online monitoring system for the lubricant health, it is very, very important to look for a complete solution provider instead of just installing several sensors on the lubrication system to just monitor some of the specific parameters. That's not going to help a lot. Actually the industry 4.0, which is actually the fourth industrial revolution, is actually towards the automation and data exchange through wireless connectivity and sensors in order to visualize the system and make very smart decisions on its own. And that's the way we have to go in the next decade or so. So while selecting the online monitoring system, it is very important to consider that there are 5 major steps which involve first is the data gathering with a quality sensor, and then communicating that data via cloud network. And then the third one is to convert that data into interpretation of that data through the proper trending features, and then identify the potential failure modes, because this is what is required to identify and detect the problems as early as possible. And finally, to raise the actionable workflows. So unless an oil analysis system or online system doesn't have all these 5 elements, it will not give the required benefits. So I think the currently the fluid intelligence is having almost all of these 5 key steps and elements in order to raise the actionable flows for the customers. Over to you, Mika.
Thank you, Muhammad. And if you, Mikko, please could go through these preliminary questions, and then let's see if we still have a few minutes time for some additional questions. So please, Mikko.
Oh, yes, very good. Oh, I hope you can all hear me. Well, we received quite a lot of preliminary questions, so we selected there 6 of them to address here due to limited time. So first one was, can I have condemning limits from OEM like GE Jenbacher? Answer is yes, you can. They are actually available in the internet, and they will be found by Google. Normally, you really should receive the condemning limits with your gas engine in the manual, or from your OEM if you ask them. Second interesting question is, how can we measure and estimate remaining oil lifetime? Okay, this is quite broad and open question, but usually there is a limits from OEM and oil manufacturers that can be helpful to define and estimate the remaining oil lifespan. Of course, you can install there Fluid Eye Trend, and you actually know exactly what is your estimated oil lifetime if other anomalies not going to happen. So, how online monitoring is the best compared to usual oil testing? Well, actually, they are not competing, but they are supplement to each other. Oil testing requires oil sampling and oil analysis, and then interpretation to tell what that situation is. This takes time, and it's 2 weeks old data in best case. So online monitoring, you know exactly where you are in right context. Oil sampling, when we have anomalies, we can have lots of supplement data out of it, relating, of course, to details such as which kind of metal might be there, but they are supplement. How do OEMs see online testing for the engine? Is there any work being done to bring OEMs on board as well? Very well. This is on our agenda too. At the moment, OEMs have been testing our system, and we are also negotiating for some of the new, and we will inform you as soon as we have some clear results. Okay. Question 5. How can we use some Infomath for online monitoring the loop oil condition that shows on DCS? The control room usually is provided by some other company than us. So basically, if you will have some connection there, we can provide an API to contact and to create a connection, but actually the DCS provider have to create a connection there. But in any case, if it's required, you can have several monitors to show your fluid hydraulic data at control room. In terms of cost, how we can show top management about the benefit of online monitoring system, this is broad question. For example, you can actually calculate it this way: that what is the current situation? How much money is spent on maintenance general to the failures that are caused by incorrect lubrication, incorrect oil in the system, incorrect maintenance practices relating to lubrication or hydraulics oils. Of course, you can calculate that how much is spent on oil itself, how much cost the oil analysis. Those can be significant also. I think my colleague Mohammed also might have comments on this.
Yeah, because my background is from maintenance and reliability. So what I would say that the management understands only the dollar sign. They only understand the money. So it is always advisable to highlight the cost of failure, how much the cost of failure occurred. As we know, the iceberg example, where the actual cost which is visible is only the maintenance cost or the material cost or manpower cost, but the actual cost, a lot of cost factors are associated with production loss. So if we add up the production loss element because of a critical equipment failure, that will be huge amount of money in terms of if you compare it with the cost of the sensors and the sensing technology implemented on a system. So it is always advisable to capture the failures, the total cost of a failure on a critical piece of kit, critical piece of rotating machine, which will definitely raise awareness within the management that if we have an online system, there will be no surprises. If we have an online system, it will be in real time, let us know what the failure, we will detect the problems in a very, very early stage, especially if the people from, in the PF curve, we will actually detect the problems ahead of point P on the PF curve. And usually other systems, the conventional way, what we are doing, it is much after the point P, which is very near to a failure, or the potentially the defect already been in an advanced stage. Okay. I think there are some questions which have been posted.
Okay, so thank you, Mohammed and Mikko, for your valuable comments. We are running a bit over time already, just so that we have 3 or 4.
Just one question. Just I saw, Mika, if you allow me for 1 minute.
Yes.
Somebody has just now asked about, what parameters, what oil analysis tests can we do through online, online oil monitoring. What test we are going to, the sensor is going to do. Can Mikko answer this? That are we doing any ISO or ASTM standard tests, which recommended by OEM? Actually, not. I think the online monitoring system doesn't measure the ASTM or ISO standard tests, because it will not measure exactly what the viscosity is, what the water content in ppm is, but it will detect the failure mode. The trend of the graph will represent what failure mode is actually happening, and it will indicate the way forward to do some exception testing in case if we need, in order to identify the actual problem. And that's what the purpose of condition monitoring is.
And there was another question that can the same sensor be used with different gas engines? So a quick answer to that. And then there was also 1 or 2 questions regarding the size of the market. So let's cover those quickly before wrapping up.
Okay, can you hear me? Yes. So basically, same sensor can be used in different gas engine types. Of course, each gas engine requires special attention where to install the sensor to have or provide the relevant data. Sensor is always as good as the location where it is sensing the oil, so it must be representative to the oil in use. And another question, Mika, was?
The one was that can we also measure basically the water for water glucose fluids in subsea industry? So
basically water glucose, if you mean water-based fluids, basically those are measurable. So, but they require special attention always.
Yeah, and then there were a few questions regarding what's basically the size of the global market for oil condition monitoring. Again, a broad question, and we can address that from many different perspectives. But if you take the oil, so heavy industry and logistics sectors, those are consuming over 40 million tons of new oil each year. So oil services, spare parts, and so on, basically comprise something like $200 to $250 billion already annually, and then the other 250 comes from the failures and the downtime. So that's basically the whole, basically the value what is around of lubrication and hydraulic oils. And of course, if you address it from the other direction, you can see it from like the IoT business perspective, for example, but then you come up with much smaller numbers. And there was also a question that what's the value or the price for installing this kind of system for one single gas engine unit. So of course, as Mikko and Muhammad previously highlighted, it depends always on the total costs, and we need to get a bit more details that what's the cost for what kind of activities you do, what are the costs for different parts, but still when you talk about like one machine measurement, we are still talking about like on 100 and 1,000 level of in the monetary terms. So of course it cannot be more basically than you have a cost base at the moment, and that we have seen really good in Vatajankoski Energy, so that they have been able to increase the reliability and also parallel reduce costs. So I think that as we had some challenges in the beginning, we are running out of time, so we better wrap up now. If some of your questions didn't got answered, during this session, we will still go through all of those questions, and we'll come back to you after the session, so you will get your answer or question answered. And as said, we recorded this session for your later use, so we will publish this in on our website, and hopefully these topics, this kind of live case examples, are interesting for you, and once we have a next case to cover, hope to see you all in this session again. So thank you very much for all of you for your participation, and our speakers Mikko and Muhammad for contributing to this topic.